Hi guys, my name is Vaishnavi. I am studying in Sri Venkateshwara College of Engineering. Subject is Computer Network. Topic is Hypertext Transport Protocol in Application Layer. Introduction to HTTP. Hypertext Transport Protocol is a foundational protocol used on Internet. It allows for the transfer of hypertext documents such as HTML files. HTTP is an application layer protocol that operates on top of TCP/IP. Historical context. HTTP was developed in the early 1990s by Tim Berners-Lee. It was designed to enable communication between web browser and server. The first version, HTTP/.9 was a simple protocol for transforming HTML. Evolution of HTTP version. HTTP has evolved through several versions including HTTP/1.0 and HTTP/1.1. HTTP/2 introduced multiplexing, allowing multiple requests on a single connection. The most recent version, HTTP/3, utilizes QUIC for improved performance and security. Key component of HTTP. HTTP operates using a client-server model where client requests a resource. The server responds with the requested resource on an error message. The communication is stateless, meaning each request is treated independently. HTTP request structure. An HTTP request consists of a request line, headers, and an optional body. The request line includes the method of GET, POST, etc., the URI, and the HTTP version. Headers provide additional context such as content type and user agent information. HTTP response structure. An HTTP response includes a status line, header, and an optional body. The status line indicates the HTTP version, status code, and resource phrase. Response headers convey metadata about the response such as content length. Common HTTP method. HTTP defines several methods with GET and POST being the most widely used. GET requests retrieve data from a server while POST requests send data to be processed. Other methods include put, delete, head, and option, each serving specific purpose. HTTP request method: get, post, put, delete, patch, head, option, trace, connect. Status codes overview. HTTP status code indicate the result of client request to the server. They are grouped into 5 categories: informational, success, redirection, client error, and server error. Common status code include 200 OK, 404 not found, and 500 internal server error. HTTP header. HTTP header are key value phrase that provide essential information about request and response. They can be categorized into general header, request header, response header, and entity error headers. Headers like content type and content length help define the nature of the data being transmitted. Cookie and session. Cookie are the small piece of data stored by the client to maintain state across requests. They are sent with HTTP request and can be used for session management or tracking. Session allows users to remain logged in and maintain a continuous experience on web application. Security in HTTP. HTTP inherently ensures as it transmits data in plain text over the network to secure data transmission. HTTPS is used to encrypt traffic. HTTPS protects against avast dropping, tempering, and main in the middle attacks. HTTP/2 feathers. HTTP/2 improves performance through multiplexing, allowing multiple requests in one connection. It allows user header compression to reduce override and improve loading time. Server push in another feather, enabling servers to send resources before the client requests them. Understanding HTTP/3. HTTP/3 is the last version utilizing QUIC and Transport Layer Network Protocol. QUIC improves latency and security by integrating TLS directly into the transport layer. This version aims to provide a faster and more reliable web experience. Proxies and caching. HTTP proxies acts as intermediaries between client and server, improving performance and security. Caching mechanism reduce server load by storing copies for frequently accessed resources. Both proxies and caches help optimize hand-wide usage and decrease response time. RESTful APIs and HTTP. Representational state transfer in an architectural style that uses HTTP for communication. RESTful APIs leverage standard HTTP methods to perform queued operation on resource. They emphasize stateless interaction and the use of URIs to identify resource. Performance consideration. Performance in HTTP can be impacted by latency, bandwidth, and server response time. Techniques like content delivery networks, CDNS, and HTTP/2 can enhance performance. Developer can optimize application by minimizing the number of HTTP requests. HTTP security best practice. Always use HTTPs to protect data in transit and ensure user privacy. Implement security headers like content security policy, CSP, and X content type option. Regularly update server configuration and libraries to mitigate vulnerability. Future of HTTP. The future of HTTP may involve further enhancement to improve speed and security. Ongoing discussion about integrating web protocol with emerging techniques continue. Innovations such as HTTP/3 indicate a thread toward more efficient web communication. Conclusion. HTTP remains a cornerstone of the internet, enabling effective communication between client and server. Its evolution reflects the changing needs of web application and user experience. Mastery of HTTP is essential for anyone working in web development or network management. Thank you.